The last couple of days we've been talking about how to graph inequalities on a number line. And just as a quick refresher, I will run through a couple of examples with you. If you are asked to graph x is less than -5, you locate -5 on the number line, you put a circle there. You have to decide whether or not your circle should be colored in or left empty. In this case, we're going to leave it empty because the symbol, the inequality symbol in this problem, is just less than. It does not say less than or equal to. If it said less than or equal to, then you would color in the circle. But because it's less than -5, that means it does not include -5. It's just the values less than -5. Because we are talking about the x's that are less than -5, that means that we are going to shade everything to the left of -5. Everything to the left of -5 represents all the x's that are less in value than -5. In this case, we're talking about all the x values that are more negative than -5. We also talked the last couple of days about how when you shade in the area, to put an X in the area that you shaded. You shaded that area, so I'm just going to put an X over it, and you're going to see why in just a minute. All right, now we're going to make this a little bit harder. What I would like you to do is in your notes, I want you to label your notes compound inequalities. A compound inequality is when you are looking at an inequality that has more than one situation going on in it. So for example, let's say that you were asked to graph x is less than 2 or x is greater than 6. If you were asked to graph this, there's two situations going on. So what you need to do is consider the first situation that says x is less than 2. So on a number line, locate 0 like usual, go to 2, put a circle there. We're talking about everything less than 2. So what I'm going to do is shade everything that is on the left side of 2, everything that is smaller in value than 2. Notice I am shading the entire number line that is to the left of 2. Do not stop at the 0. Keep going. Shade everything to the left of 2. But then there's also this situation over here that says that x could also be greater than or equal to 6. So you need to locate 6 on your number line. We'll say 6 is right here. I'm going to put a circle there. Now this time I'm going to color in the 6. And the reason I'm going to color in the 6 is because of that greater than or equal to symbol. That means you color it in. But it also tells you that you are talking about all of the x values that are greater than or equal to 6. That means you shade everything to the right side of the 6. So this number line represents all x values that are less than 2 or the x values that are greater than or equal to 6. Now earlier we talked about putting an x in the area that you shaded. So what I'm going to do is put an x here, and I'm also going to put an x over here in the other area that I was talking about. Now the reason I'm having you do that is because if you look at the original problem, x is less than 2 or x is greater than or equal to 6, there are two x's in that situation. There's an x with the less than 2. There's also an x with the greater than or equal to 6. That means to you, because there are two x's, that you are actually going to have two shaded regions on your graph. So keep that in mind. If you have two x's in your compound inequality, you have to have two shaded regions on your graph. If you only have one x in your compound inequality, then you will only have one shaded region in your graph. Let's try another example. Let's try graphing all of the x values that are greater than or equal to -2, but they also have to be less than 3. So first of all, I want you to notice that there is only one x. There is only one x value in this compound inequality. So that means when you graph this on a number line, you are going to graph only one shaded region. There's your number line. I'm going to put -2 over on the left. I'm going to put 3 over on the right. I usually ask you guys to locate 0 too. Don't have to, but it's helpful. So at -2, the -2 is with the greater than or equal to part. So that means at -2, you're going to put a circle, but you have to color it in. And then if you look at the 3 part of it, that goes with the symbol less than. X is less than 3. So I'm going to go to the 3. I'm going to put an open circle. I'm not going to color it in because it's not less than or equal to. And remember how we talked about because there's one x in the compound inequality, you are only going to shade one region. One x means you shade one region. So I am going to shade one region on this number line. It only makes sense to shade the region that is in between the -2 and the 3. But let's go back to the inequality. The inequality says that we are talking about all of the x values that are greater than or equal to -2, but also the x values have to be less than 3. So we have two situations going on. Greater than -2, but less than 3. So that means we are talking about all of the values in between the -2 and the 3. Remember, 1x means you are shading one region on your number line. Let's try a couple of more examples. Let's go back to the basics. What if it just said x is less than 5? If it just said x is less than 5, you go to 5, you put an open circle, you shade everything to the left of it. But if I add something to that and say, okay, or it could be all the x values that are greater than 6, then what you need to do is add 6 to your number line. I'm going to put another open circle, and it says x is greater than 6. So I shade everything to the right of the 6. All right, what if I did this? X is greater than or equal to -4. So on a number line, if I shaded all the values that are greater than or equal to -4, that means I go to -4, I put a circle there. Because there is a bar underneath my inequality symbol, I am going to color in the circle. And I need to shade all of the values that are greater than or equal to -4. So where are the numbers on this number line greater than or equal to -4? Well, it's everything to the right of -4. But if I add something to this, and say that it has to be all the values that are also less than, say, 2. I need to locate 2. I need to put a circle there. If we're talking about all the x values that are less than 2, we are talking about the x values that are to the left of 2. So I shade everything to the left of 2. So I'm shading the region that is bigger than -4, but less than 2. Notice again, there's one x in this compounding inequality, so I need to graph one shaded region. Let's try a couple more. What if I ask you just to graph x equals 5? X equals 5. Well, that is one solution. We have one solution, and it is only at 5. So on a number line, you go to 5, and you put a dot. That's it. What if I ask you to graph x equals 5, 6, and negative 1? Well, you would add a 6, put a point there. These are all equal to. We're not talking less than or greater than. We're only talking equal to. But also negative 1, so I go to negative 1, and I put a point. So I have a negative 1, I have a 5, and I have a 6. Sometimes I will give you the number line, and I will ask you to write an inequality. So let's say you have this situation. You have a 3 on the left side, you have a 5 over here, you have a colored in circle with the 5, but an open circle with the left. You've shaded everything to the left of the 3, everything to the right of the 5. We have two situations going on. We have two x's. We have an x over here, we have an x over there. In other words, we have two shaded regions. If you have two shaded regions, that means you have to have two x's when you write your compound inequality. In this situation, we have a bunch of x values that are less than 3. Everything to the left of that 3 is less than 3. Or, don't forget to use the word or, this big empty space in the middle, that's representation of the word or. So we have x is less than 3, or we have a bunch of x's that are greater than or equal to 5. One more example. What if we have this? We have a number line, we have negative 3 on the left, we have 4 on the right. Both circles are colored in, and we've shaded everything in between. We have one x value, because there's only one shaded region. So when you write your compound inequality, you are only going to have one x in your answer. So I'm going to put an x here. Now, the shaded region is x values that are greater than or equal to negative 3, less than or equal to 4. Now you get to try some.